Asteroid Structure Insights.
Ever wondered what happens when you punch a pile of gravel versus a solid brick wall? That's exactly what DART's collision revealed about Dimorphos, and honestly, it completely shattered our assumptions about asteroid composition. Before September of 2022, scientists believed most asteroids were dense, rocky bodies that had formed billions of years ago during the early solar system. But when DART slammed into Dimorphos at 14,000 miles per hour, the impact didn't create the expected solid crater. Instead, it triggered what researchers called a catastrophic disruption that exposed the asteroid's true nature as a gravitationally bound rubble pile. High-resolution images from ground-based telescopes showed massive boulders, some the size of school buses, being ejected from the impact site, revealing that Dimorphos is essentially a loose collection of rocks held together by extremely weak gravitational forces. This discovery revolutionized our understanding of near-Earth objects, with Dr. Andy Rivkin from Johns Hopkins Applied Physics Laboratory confirming that 80% of asteroids in our cosmic neighborhood share this rubble pile structure. The implications are, well, staggering. These flying gravel heaps are much easier to deflect than solid asteroids, but they're also way more unpredictable in how they respond to impacts. Spectroscopic analysis conducted in late 2022 revealed that the ejected material contained primitive carbonaceous compounds dating back 4.6 billion years, making Dimorphos a time capsule from the solar system's violent birth. This insight means future deflection missions will need completely different strategies depending on whether they're targeting solid asteroids or these cosmic rubble piles.